Hello, everyone. Welcome to Dev Days Europe. You're on stage 6. My name is Christina Koleva, and I'll be your host today and tomorrow. And we're starting today with a very important topic with David Spinks, who is the embodiment of an agile coach for me. He's Kanban coach, Scrum trainer. He's the co-author of Mastering Collaboration in a Product Team and Adopting Agile Across Borders. He's passionate about making teams and helping them make the best out of agile processes. And today we're talking about something essential, why agile engineering practices are essential for achieving agility. David, is there a double standard? We're given plenty of time to adopt a new process, but doesn't that time eat our tech debt time, for example?
It's a great question, and it's a great lead into what I'm going to talk about today. I think I don't think you can kind of isolate delivery and investing in agile engineering practices. I think it's something you've got to think about in parallel, as we're going to see as we go through the talk today. Yes, maybe we want to focus on delivery, but I think that's a short-term mentality. If we're going to think about sustainable long-term delivery, we've got to think about this investment as we go. So hopefully that answered your question, and that's a nice tease for the talk today. Okay, so shall we make a start with the talk? So hi everybody, welcome. Thank you so much for joining my presentation. So as we said in the introduction, this is all about why agile engineering practices are essential to achieve agility in software development. And most importantly, why everybody should care about this and not just engineers. So just to formalize some of the introduction, a little bit about me. So I started my career as a software developer a number of years ago. Somehow I became a team leader, and then I got into Agile. I became a Scrum Master and an Agile coach. So with my technical and Agile background, I feel like I've got a good understanding of the importance of good engineering practices in order to enable agility. As mentioned, I'm an accredited trainer with both Kanban University and Scrum.org. I think it's important to mention that I'm not particularly attached to any process. I love learning, combining ideas from a broad spectrum to find what works in context. As mentioned, I'm also a published author of the books Adopting Agile Across Borders, and this looks at the impact of culture on Agile adoptions. I'm also the author of the book Mastering Collaboration in a Product Team, and this is about sharing techniques that product teams can use to collaborate in developing products. I've also got a third book coming out later this year called Facilitating Professional Scrum Teams. I'm the co-founder of a company called Red Tangerine, and this is the company through which I offer my training and consultancy services. But that's enough about me. So let's get started with the content of the talk. Let's start with the term agility. So DevOps is one way to achieve agility. But what do we actually mean by agility? The Oxford Dictionary defines agility as the ability to move quickly and easily. If we look at this definition, it may be understandable that many relate agile and agility to speed, but I think this is unfortunate. For me, I much prefer this description, which came from the field of sports science. This is from a couple of people called Shepherd and Young, and they describe agility as a rapid whole body movement with change of velocity or direction in response to a stimulus. So agility is often used to describe a change of direction of speed. However, there's a distinct difference between thinking about agility and just changing direction. Agility involves reactive abilities in unpredictable environments. Changing our direction of speed, on the other hand, focuses purely on trying to maintain speed as the direction of travel is changed. But this is usually only possible when each direction of travel is known in advance. For example, if we think about the sports analogy, if I think about a game like football or soccer, we would say that a defender is reacting to the attacker's sudden movement in an agility-based movement. They have to react based upon what the attacker is doing. If I compare this to an athlete who's running through a course of pre-positioned cones, they're zigzagging through, or a skier slaloming down a ski slope, the reactive component is missing. There's no impulsive or unpredictable events happening that the athlete or the skier is having to react to. They're just going through the cones or the flags, and it's about changing the direction of speed only, not about reacting to changes in the environment. So more and more companies are adopting agile ways of working. However, this growing popularity does sometimes result in agile ways of working not living up to expectations for some of the companies adopting it. Why? Because, well, when I ask leaders of organizations why they want to adopt agile, a common answer is that they want to deliver faster. In this case, they're thinking of agile as the example with the athlete or the skier, trying to go as fast as possible through a pre-planned route. The athlete tries to reach each cone as quick as possible and then move in the direction of the next cone as fast as they can until the end of the course. This is like when a project scope is set and teams are working in short iterations in which they deliver the planned feature as fast and efficiently as possible before moving on to the next one. So this is all fine in a predictable environment where the plan does not need to change, where requirements stay fixed, where the market stays the same, and where customer behaviors are well understood and set in stone. But these are not the environments that Agile was designed for, and not the environments that a lot of the companies are operating in. Agile was created for environments where change is constant. Customer expectations, behaviors, market trends, the actions of competitors, all of these things are changing in our environment. These are what we call the VUCA environments. These are the environments that are volatile, uncertain, complex, and ambiguous in nature. Here is where there is a need to react to new information and changing circumstances, or in other words, where true agility is needed. If we look at frameworks such as Scrum, these are meant to support agility. We've got the sprint, which are short planning horizons, and we've got the artifacts and events in Scrum. They're there to provide greater transparency and opportunities for teams and organizations to inspect and adapt based on early feedback, changes in conditions, and new information. We can think about a sprint as a very short-term planning horizon, and we can change our plan sprint to sprint. So it gives us an opportunity to pivot and react in a timely manner. However, Scrum is often, unfortunately, misunderstood as a mechanism to just deliver faster. So over the years, I've encountered many agile adoptions at companies where a lot of energy, focus, and budget went into training and coaching people in implementing certain frameworks, such as Scrum or other ways of working. The goal of this was to understand and ensure all of the framework elements are in place, such as the required collaboration meetings, that the accountabilities are understood, and the team structures are put in place. People are asked to participate in numerous workshops to learn about agile ways of working. However, what I don't encounter so much are companies spending the same amount of energy, focus, and budget in helping to ensure teams have the time and ability to use good agile engineering practices that are also enablers for agility. There might be some initial investment in setting up a build pipeline, for example. However, investing time in learning and practicing good engineering practices oftentimes takes a backseat. When challenged on this, responses are typically something like, "We don't have time for that now," or "Let's just deliver the next release and we'll look at doing it at a later date when we have time." And that time usually never arrives. So focusing only on speed and delivery and not investing in agile engineering practices will eventually slow things down in the long run. It becomes harder to maintain that direction of speed, let alone to increase it, and any semblance of agility is a fantasy. When teams are put under more pressure to just go faster, they consciously or subconsciously start to trade quality for speed. Technical debt starts to build up and things become unsustainable. My dog Fred is going to demonstrate this with a short video. So this is Fred's backlog. He is being asked to deliver balls. Off he goes. First ball delivered in 14 seconds. Five balls in 53 seconds. So looking at the backlog, lots of requests for ball delivery. But the next item is to cut the grass. But our customers don't want that. They want balls delivered. So we're going to deprioritize cutting the grass. Some time later, many requests coming in. Cutting the grass is still deprioritized. Let's look at the consequence of that. Much harder work for Fred to deliver this ball. Finally, he found it. So now it took much longer to deliver one ball than it did 5 balls just 3 weeks ago. So this is a nice analogy, a very simplified example, but does show what can happen if there's only a focus on delivery. We know that we should be doing things differently. We should be investing in our process, our engineering practices, but there's still the feeling the most important thing is to get stuff done. But if we don't keep on top of our engineering practices, our technical debts, as Fred showed us, our weeds might grow out of control, and that can have a detrimental impact on customer delivery on the long term. So making maintenance and quality an ongoing part of the work, including investing in engineering practices, helps to prevent an accumulation of things that will slow us down in the long run. So let's go into a little bit more detail of my experience anyway of what happens when we don't invest in keeping technical debt down and investing in our engineering practices. I've seen a pattern like this again and again in my career. For example, a company has a goal to build a new e-commerce platform. They want to sell goods through their new site. They deliver their first slice of functionality in a 1-month sprint. And the first slice is a static catalog page on which products can be uploaded with a short description. The first delivery is made, it's received by happy and excited stakeholders, and they're hungry for more. And since the team have learnt about the Agile principles, and one of them is satisfy the customer. So they keep on building and the product keeps growing. Over time, stakeholders make more requests and the team works harder and harder to keep up and deliver at the same pace, at the pace that they feel that the stakeholders expect from them. The team, they don't have time to invest in automation or any other agile engineering practices. They are still testing manually, so the manual regression testing becomes a bigger and bigger burden, and it becomes more challenging to be completed within a sprint. The code base itself becomes more complex, more brittle, and the product becomes more bloated. So the team struggles to deliver at the same pace. And they struggle to try to meet the expectations, and so they start to cut corners. The team keeps telling themselves that now is not the right time to invest in their engineering practices. They need to keep delivering. They end up doing things like carrying testing work over from one sprint to the next, and there's no time for validating if what is being delivered actually produces value. which is just as well because they haven't had time to set up any analytics. It's all about focusing on delivering more and more features. So we end up in a situation where the team is busy trying to build more and more new features, but more of their time is spent on manual integration and regression testing, for example. They don't have time to look at other improvements, such as to that original build pipeline. Consequence of this is that a release to production may take several hours, might mean that they have to take their website down for a number of hours. And so this has to be done overnight and manually. So again, that means engineers have to stay late, work overnight. So again, they can't contribute as much the next day. To make matters worse, the market has been changing. The sales team in the company, they've made new deals with new suppliers, and this means that there's more customizations needed, more features. The company is also pushed for the platform to be available in different time zones. So now the downtime for release is now a big problem. And so this must be minimized. And so releases are only allowed to happen once every 6 months. So progress in terms of actual delivery to the end customer comes to a standstill. The product becomes riddled with technical debt. The team has lost the ability to get early feedback and the ability to react to what their attackers are doing, i.e. the changes in the environment that we discussed earlier, such as customers changing their needs, the competitors' actions, changing market conditions, etc. So, of course, a framework like Scrum can be used without using any agile engineering practices. It's not mandatory. After all, Scrum is just a framework. However, without good engineering practices and without striving for technical excellence, as we've seen, a team will only get so far and can fall into the situation that I've just described. So just implementing the mechanics of Scrum does not ensure agility, and it does not automatically lead to a more beneficial way of working. The Agile Manifesto includes principles, not just satisfy the customer, but there's principles such as continuous delivery of valuable software. And by valuable, we also should be thinking about good quality. Other Agile Manifesto principles include continuous attention to technical excellence. Another one is at regular intervals, the team reflects on how to become more effective. So following these sorts of principles are a far greater enabler of agility than following the Scrum framework alone. And one effective way of enabling greater agility and living those values is to complement something like Scrum with agile engineering practices. So we're going to have a look at a few of the engineering practices that I'm talking about. I want you to note that there are plenty more out there. You'll probably learn more about other engineering practices during this conference. So these are just a small sample. Many of these practices, they trace back to extreme programming from Kent Beck, Ron Jeffries, and Ward Cunningham, who started that movement. I think that was back in the 1980s. So even though some people might regard these practices as DevOps practices, a lot of them have their roots from extreme programming. So they've been around a while. So let's start with pair programming. Pair programming is often misunderstood to be two people working together at the same computer. It is often criticized, therefore, for being wasteful. But let's face it, there's perhaps bigger sources of waste within companies, as this cartoon hints at. Proper pair programming involves one person acting as what we call the navigator and the other as the driver. Only the driver touches the keyboard and the mouse as the navigator directs them in what they're doing. The two different roles means that there's two different perspectives. The driver can think about the small, immediate tactical task at hand, while the navigator can think about the bigger picture. They can think more strategically. They can think about what they're doing and how it fits around the whole code architecture, for example. So pair programming involves a lot of communication between the two engineers. It's not just about producing code, but about producing well-designed code. Because we've got two people working together in real time, it means that code reviews are done in real time. So it means that we can do our conformance checks to standards uh, at the time that the code is being written. This reduces the risk of inadvertently adding bugs or introducing technical debts, and it means that we can ensure this quality at the point it's cheapest to do so. In other words, as the code is being written. A lot of companies will have code reviews, but by using pair programming, we are reducing the delay of waiting for a separate code review, where one coder working in isolation writes their code and then asks somebody else to review it. They have to wait for that somebody else to become available. So with pairing, we're doing it in real time. There's a few variations of paired programming. One of my favorites is called promiscuous pairing. This is where a team or a group of developers will work in pairs, but they will regularly swap who works with who. So they're switching out the pairs maybe every 30 minutes, every 40 minutes, something like that. There's also something called ping pong pairing, and this incorporates a test-driven development approach, and I'll come on to talk about that in a few moments. So whatever the form, pairing is a great tool to encourage collaboration within a team of developers, a team of engineers. It promotes great communication. It helps developers learn from each other, as well as having been proven to produce higher quality code, like I say, less technical debts, reducing the need for rework and bug fixing later. So let's move on to talk about test-driven development next. This is sometimes called test-driven design. So TDD for short is a disciplined approach that follows what we call the red-green refactor cycle. The way that this works is, first, the next simplest test is written. What's the next simplest thing I want to test for? Now, because there's no code yet, because we're writing the test first, then we're in this red phase. Now, the next step is to move into the green phase. We need to make that test pass. And we write just enough code, just enough implementation code to make the test pass. And I mean only just enough. For example, if my test is calling a brand new validation method and the test is expecting a true response, I will literally code return true just to make the test pass. Now, once I've got the test passing and all of my other tests are still passing, we can move into the refactor phase. So the coder or the coders, if we're pairing, they look at the code and decide if it can be improved to make it more maintainable, cleaner, and easier to understand. Here, as part of this refactoring, we're not thinking about changing the logic, but just making the code cleaner. Now, because I'm writing my code test by test, I might end up with a very messy and long method. That return true, I might have lots of conditions around it. I might have a very messy method eventually. So in my refactor step, I'm now being driven to actually introducing a good design pattern. So good knowledge of design patterns and coding principles, such as the solid principles, is really needed for this kind of refactoring. I thoroughly recommend the book Design Patterns by the Gang of Four when it comes to object-oriented programming languages for this. It's a few years old now, but it's still very much relevant today. So after refactoring, the tests can be run again to ensure that the functionality still works and nothing was broken. For me, it's really important that TDD is followed in this disciplined way. We don't want to start refactoring the code while we're still in the green phase, while we're still trying to make a test pass. Because if my tests are failing, I don't know it's because I've refactored something or because of some new code that I've been added. So once I've done my refactoring step, I can run my tests, make sure everything is still green, and then continue with the next test. So the tests, they form a kind of insurance policy, allowing me to refactor with confidence, making sure I don't inadvertently break things. So it's not just about creating the tests and having a test suite. Because the code is being built up step by step through the addition of tests one at a time, the design of the code is also driven by the tests. At some point, I'm going to have to refactor that return true code to make other tests pass. But the point is that there's no need to design the code up front. The code evolves in response to making the next test pass and then refactoring to make it cleaner. So TDD is particularly effective when we need to tackle a complex problem, when there's no obvious design up front. It is probably unhelpful to approach TDD dogmatically and to always use it alongside pairing for everything. It's probably not necessary for simpler tasks. I mentioned TDD and ping pong pairing can be a great combination. So for example, we could have person A, person B, they're working together. Person A starts as the driver when the pair writes a failing test. They then swap roles. Person B becomes a driver for the pair, and then they start writing the implementation code to get the test to pass. Person B, they stay as the driver, and they write the next failing test before they swap roles again for person A to drive, and this time they write the code to make the test pass, and so on. So remember that each time the pair have written just enough code to make the test pass, they must think about the refactoring. In this way, we're following this disciplined red-green refactor approach. Write a failing test, make it pass with the minimum necessary means, and then refactor for cleanliness and maintainability. So as you can probably tell, I'm a big fan of TDD. There's many benefits to TDD and pairing. It's great for knowledge sharing. It's great for onboarding new team members, gets those people up to speed with the code base. It combines two different modes of thinking as the code is being written, strategic and the detailed. It encourages collective code ownership. We don't have the coders or engineers just working on the pieces of code in isolation, feeling that they own a piece of code. It helps to create focus. It helps to keep work in progress low, which reduces context switching, which can be very wasteful. It should help the team gravitate towards good design patterns. It increases quality with cleaner and more maintainable code. As I've said, it enables code reviews on the go, reducing delays waiting for code reviews. It results in very good code coverage, but also code coverage with meaningful tests. So you're more likely to build the right thing because code is driven by the tests, which are in turn driven by the requirements. Which takes us beyond TDD and other test-first engineering approaches, which include things like behavior-driven development, acceptance test-driven development, and specification by example. I'm not going to go into those, but they all help to drive development through defining the tests first, or how we expect the functionality to work. And we can get other members of the team writing particular tests, QA people, analysts, and we're starting to blur the line between requirements and code here. And this means that we are reducing the misunderstandings when requirements are handed over in a document, for example. It improves understanding of what we want to build and improves communication. So I just want to point out there are some downsides with these techniques. Pair programming can be very tiring. It can be difficult for people that are more introverted. So I'd always advise to limit the amount of time that team members spend pairing. As mentioned, there's also some people that will see pairing as wasteful because they see that they're paying two people to do the job of one. So convincing some people of the benefits can be a challenge. I'm going to mention mob programming. This takes pairing a step further. So mobbing is described as an all-team approach. In a nutshell, with mob programming, the whole team works on the same thing at the same time, in the same space, and at the same computer. So similar to pair programming, but mobbing includes the whole team, or at least as many members of the team as possible, while still using a single computer for writing the code. There's still one driver, but everybody else is a navigator. Mobbing is a whole team collaboration approach to get a unit of value delivered quickly with high quality. I have seen some organizations doing this. They've even created mob programming stations with one big screen, one desk with one computer, and a layout of chairs around the screen. So again, it's about focusing and getting a unit of value delivered as soon as possible. A similar approach is called swarming. Again, the whole team or as much of it as possible are involved in working on a unit of value. Could be a product backlog item or a single user story. But here, everyone is not necessarily at the same computer, but different tasks for that user story are happening in parallel. The main goal remains for the team to focus their work on achieving a single outcome, a single unit of value. Okay, so it's not about utilizing people, it's about utilizing getting the work done as fast as possible, that unit of value. So next, I want to talk about continuous everything. Continuous integration, continuous delivery, continuous deployment. So these are engineering practices that help us to build in quality, to shift things to the left, as we say in DevOps. And we do this by focusing on the flow of delivering value, but also building in validating feedback loops earlier in our process. So we'll start with continuous integration, and this is the practice of a developer continually integrating their changes with other developers. So if a developer is working for many days in isolation in a separate code branch, they're not practicing continuous integration. So to do it well, each programmer should be integrating their changes into a shared branch several times a day. Builds and test runs are automated as code changes, making integration a part of the natural rhythm of developing the software. The longer a developer takes to integrate, the bigger the change and the harder it is to integrate with everybody else's work. Therefore, with CI, the idea is to make progress in a series of small steps, maintain quality, and ensure that integration issues are minimized. So if we're not doing CI, think of the consequences. Think of a team of developers working in a 1-month sprint, and they merge all of their work in the last days of the sprint. If, or should I say when things break, it's much harder to work through 1 month's work of everybody's work in the whole team to figure out what the issues are, as opposed to one very small change that was only just made. So continuous integration reduces the risk of bugs, it reduces the pain of integration, it improves quality, and it reduces the need for massive regression test phases. We can have confidence that we've got a good quality product throughout the whole process, and we're not relying on this regression test phase towards the end of the sprint or the end of our project. So continuous integration is a precursor for continuous delivery and continuous deployment. So let's talk about those next. So these terms, continuous delivery, continuous deployment, are often used interchangeably and sometimes incorrectly. Continuous delivery is the state of having the latest version of the code ready to be deployed at all times. Martin Fowler is a thought leader in the software development industry, and he puts it like this. A stakeholder asks you for any version of your code to be deployed to an environment, and nobody panics. So this requires good quality automated test suites that are well maintained, automated builds, build and deployment pipeline set up for all of your environments, and continuous integration servers in place with continuous integration properly followed. So while continuous delivery is about having the latest version of the code ready to be deployed at all times, with continuous deployment, the deployment happens automatically. So at the point a programmer checks in a piece of code, it is integrated and automated tests are run. It is automatically built and deployed to target environments, which could include environments for automated test suites to run, which could include acceptance tests. So provided everything passes, the code that can then be automatically deployed to production. So to stress, this is all triggered on the developer's check-in. If at any stage there are any integration issues or failing tests, then the deployment is stopped and this is fed back to the developers to fix. So this is the ultimate level of agility with rapid deployment of value and fast feedback. So with practices such as CI and CD and other practices, there's something called blue-green deployments, which I'm not going to go into. But with these engineering practices in place, releases can become a non-event. Amazon, for example, they're famous for deploying to production every 11.7 seconds. And this was the last time they released their statistics, which was several years ago now. So this allows them to deliver value, test ideas, get feedback, and roll back if they need to, all at pace. So while we can't all be Amazon, it does show the levels of agility that can be achieved with the right investments in these practices. So many of the agile engineering practices can be viewed as daunting and expensive to implement. People worry that investing in them will get in the way of actually delivering. However, I would argue that building in quality and automation enables sustainable development in the long run. Good engineering practices avoids products becoming overburdened with mountains of technical debt that cannot be paid back. It's not just about enabling agility, it's the professional thing to do. Agile engineering practices are essential to achieve agility in software developments. It allows us to get the benefits that I talked about earlier, value to stakeholders, react to changing environments, etc. So while investing in agile engineering practices may seem to slow things down in the short term, the aim is to actually maintain a speed and increase it in the future while still retaining that ability to pivot. So to finish, before we go into Q&A, I want to mention one other thing. As well as investing in good engineering practices, I'd love to see companies investing more in good engineers. I've noticed that people are often rewarded with promotions, often taking them into management positions and away from being hands-on with the technology. This seems to be the only route in a lot of companies for people who want a significant pay rise or other benefits. But the result is that good technical people spend less of their time doing technical things. So I'd love to see an alternative where people are rewarded who grow horizontally. What I mean by this is that people are rewarded when they learn new skills, expand their knowledge of their craft, not just great coders, but great implementators of engineering practices that I've been talking about. They keep up with the latest technology trends. So this growth also could include mentoring others and passing on their great knowledge. So these people can help organizations make good technological choices and align that with the organization strategy. And all of this will help enable the agility and sustainable delivery that I've been talking about. So these people bring as much value to those that are moving into the management positions. So if we can give the company a competitive edge through great technology practices, great engineering practices, why not reward people that are helping organizations with this evolution? So for me, it's important for everybody to truly understand the importance of investing in good agile engineering practices, as well as good engineers, and the impact on agility if we don't do it. So creating a shared understanding of the challenges that teams face and the trade-offs for short-term speed without good engineering practices in place can be a good starting place to begin the conversation. But to summarize, if we want sustainability of pace, if we want robustness, if we want quality, good customer service, if we want fitness for purpose and true agility, there needs to be continuous investment in good engineering practices. Thank you once again for coming to my talk, and I'm happy to respond to any questions that you might have.
Thank you so much, David. It was a great start for today's conference day. Yes, we have questions. So without further ado, the first question is from Alina. How to strike balance between technical excellence and falling into the rabbit hole of future-proofing the code and seeking perfect code solution, even though that perfect may not be currently required or may have questionable product value? Great question.
Yeah, really good question. Yeah, thank you for that. Yeah, it's a tricky one. And as an ex-developer, I kind of understand where we're coming from. I mentioned there was an acronym that I used earlier, SOLID. There's another acronym that you might have heard of called KISS, Keep It Simple, Stupid, it's short for. So this is why I think pairing is such a good practice. In something like Scrum, we've got the definition of done. At a minimum, a good practice to have as a team is what are our coding standards. As a pair, as you're creating the code, you can talk about, are we conforming to the standards or not? And at some point, you might get into that situation that the questioner has described there. We're arguing about, oh, are we going to future-proof this? Are we going to make this better? What I would like to see is maybe bring in a third person from the team to arbitrate. If we've got two people thinking, oh, we should future-proof this, should we not? Maybe bring in a third person to kind of say, I think this is good enough, or we should be making it a bit better. But also, I think this is where something like TDD is a very powerful practice. Again, because if I'm doing something like behavior-driven developments, I've got a test that describes the behavior. I'm then writing my unit tests to build my code to then make my behavior test pass. Okay. The tests are driving my implementation. So I shouldn't be thinking about future proofing because my task is to make the next test pass. So it's all about the preparation work on defining good tests, good behaviors at the start. So for me, it's less about the actual engineering side and more about the refinements of your product backlog items, the refinement of your user stories to define good acceptance criteria, which will define good behavior tests, which will define good unit tests. And then the engineering is just about making the test pass.
Thank you for that answer. I have personally heard a head of product to make the difference between falling into the rabbit hole of endless refactoring versus delivering product value. There shouldn't be any difference, right?
Yeah, I do hear that a lot of the time. And again, refactoring is one of these words which is often thrown around and not used properly. And I hear refactoring sprints or refactoring projects, and it's like, that's not refactoring, that's redesign. All right. So refactoring, like I say, we should have the insurance test policy of, we've got certain functionality that exists. Refactoring is just about making it cleaner and more maintainable. If we're having to redesign our code base because of poor quality, that's not refactoring. That's almost like a mini project.
We have another question from Rami. We understand that the continuous development integration is needed, and as mentioned, some individuals might not want to pick this up due to it hinders my progress. How would you approach encouraging these individuals to use CI/CD and make them excited, not just tolerate it because they have to?
Yeah, it's a good question. I think I would take an agile approach to implementing some of these engineering practices. What I would not do is go back to the office at the end of the conference and try to implement continuous integration, continuous delivery, continuous deployment, blue-green refactoring, blue-green deployments, all of these DevOps practices all at once. It will be too much and too daunting. So I'd always bring it back to, hopefully you're having team retrospectives. What is your biggest problem? What pain could be helped by introducing a new practice? So when, again, I'm looking at the wording of the question here, do we have to do CD, CI? Well, no, it's kind of up to you. But I've been involved in enough projects to have gone through the pain of not having it. And chances are you're already feeling some pain. Are you in the situation that I've described during the talk? Are you getting to the end of your sprints and you're having this big integration phase with lots of difficult test phases? I've seen it time and time again where a team will have a sprint where the developers are busy at the start of the sprint and test people, QA people, have got nothing to do. And then at the end of the sprint, it's the opposite. Okay, so by first articulating a challenge, you can then think, is there an engineering practice that can help to solve that problem? So what I've just described there, by talking about continuous integration, can maybe smooth the flow of code being checked in to be tested to solve that particular problem. So yeah, to summarize, don't try to do everything at once. And again, bring it back to what problem are you trying to solve?
Yeah, we don't have to do it, but it will be good for us as engineers. It will be good for the product.
Yeah.
It will be good for the entire company at the end of the day.
I think past experience is a good thing. Maybe you've been in an organization or a team where you've had technical debt, where it's been very painful to deploy. So I think experience of what happens when you don't do it, again, you can talk about that as case studies with the people that can help make those decisions.
Thank you for answering. I have one more question. Why do we fail to identify waste?
Why do we fail to identify waste? That's a great question. I'm going to expand on that a little bit, because I hear a lot of organizations, they try DevOps, they try Agile, they try Scrum, and it doesn't work for them. And the question is, why? Scrum doesn't work for us. Well, why? What's missing? And fundamentally, people are trying to get the mechanics right. But at its core, something like Scrum is about the fundamentals. Purpose of doing Scrum is the empiric process. It's about being transparent as well as enabling inspection and adaptation. So it's that transparency bit that I think is the hard part, because if I go back to that previous statement, Agile doesn't work for us, DevOps doesn't work for us, Scrum doesn't work for us. Well, what Agile and Scrum and DevOps, they won't fix your problems, but what they will do is make your problems more transparent. And that's why we think Scrum doesn't work, because, we're seeing all these problems. They were always there. It's just become more obvious because of these things that we're doing. Okay, but this is a very difficult cultural thing, and it requires a cultural shift within teams and organizations to have the courage to be transparent. So part of it is showing the problems that the company have got, this dysfunctions, and being willing to do something about it. But I think part of the culture of a lot of organizations is it safe to do so? Will we get punished? Is it just easier to kind of hide the problems and then show that things are successful? So again, part of this is, again, we don't have time to talk about it today, but part of adopting things like DevOps and Agile and Scrum is an organizational change, and that includes the culture to be transparent, to feel safe, to be honest about what's actually happening.
Thank you so much, David. That last question was, of course, to enhance on all of the great insights you shared with us today. There are no more questions from the public. Thank you for being part of Dev Days Europe. Thank you, everyone, for joining us for the first lecture, and we'll see you in a bit. David, thank you so much.
Thank you very much, and thank you for coming, everybody.
This is all we got. Remember the revolution in our minds. This is all we got.
Lock me out of this life institution. I am angry and I on illusions. Yes, I hate, but it's not a solution. Try my best, but I'm just a human. Oh, we don't need to say we're sorry. We don't need to worship ever sorry.